Okay, so we're going to continue with our instant calculations. We have a question that we'd like to explore here. The question reads as follows. We're going to do B there, which says find the angle of elevation theta of a gun which fires a shell with a muzzle velocity of 120 meters per second and hits a target on the same level but 1,300 meter at a 1,300 meter distance. So I'm interested here in the diagram. So here's the diagram. So let's look at what can be done to make this calculation. Okay, so we're going to look at the information that we're given. So we are told here by the question that we need to find the angle, and we are told that there's a muzzle velocity of 120 meters per second, so we're given 120 as our velocity. We're also told of the horizontal displacement, which is 1,300 1,300 meters. So with that information, we must be able to calculate our angle to horizon. So this is the angle of elevation. So this is the calculation. We use that parabolic total distance equation, dO is equal to v squared sine 2 theta over g, and we substitute what we're given here. We realize that we get an angle of 31.16 degrees. Let's find another question. Let's find another question here. So there's another question. A baseball is thrown with an initial velocity of 100 meters per second at an angle of 30 degrees above the horizontal. So we're given here velocity, initial velocity, and an angle above the horizontal. There's also a diagram. So let me show you the diagram so that we are on the same page. So here is the diagram. So this is the situation that we have. Okay. So so the question says here, how far from the throwing point will the baseball attain its original level? So let's look at what we're given here. We are told that the initial velocity of the ball was, so the velocity was 100 meters per second. We are told that the angle to the horizon was 30 degrees. We are asked here, given those two variables, to determine how far from the throwing point the baseball will attain its original level. In other words, how far from the throwing point will the baseball land? So that's horizontal displacement. So it's going to land some 882.8 meters away from the throwing point. So again, our parabolic total distance equation, dO, is equal to v squared sine 2 theta over g. We substitute and we find the total distance of the baseball. Let's see if we can do one more question. Let's see if we can do one more question. Okay, for now let's end here. We'll pick up on more questions in the next video. So join our WhatsApp groups. You can throw in a question and you'll get an instant calculation. You'll get a video explaining things to you. If you need to dive deep into the concept, you can always contact me for lessons. You can always contact me so that you get further explanations. So see you in the next video where we'll do some more instant calculations.